So if we're going to evaluate the benefits and the costs of doing something, so the government undertaking some policy or a firm deciding to undertake some investment in a factory or some technology, or just an individual choosing, should you go to college or not, or should you invest here, or should you, whatever, anything where you're weighing the benefits and the cost, it's important to realize in a lot of cases, the benefits and or the costs don't just happen now. They're a multi-year, they take place over a long period of time. So you pay for college now, but the benefits of going to college accrue for all the rest of your working life if you earn more, or any other benefits there are. And so, or if you build a new factory, the benefit of having that factory is going to accrue long into the future while the costs are upfront. And so, or thinking about something like global warming, climate change, the cost of combating it we're going to incur now, and the benefits again are going to be somewhere in the future. And so we have to take into account, if we want to weigh the benefits and the costs, we can't treat the benefits and costs that accrue in the future and the benefits and costs that are occurring right now as the same. And that's where this concept of present value comes in. When we want to evaluate the benefits and costs, we want to make sure we're comparing the same things. And so we want to compare the present value, what it's worth in right now terms, the present value of the benefits with the present value of the costs. And you see a lot of numbers up here and you're like, oh, well, that's going to be something complicated, I'm not going to understand it. But you already understand it because you know this. Would you rather have $1,000 now or $1,000 in 10 years? You'd obviously rather have $1,000 now, or I assume that you would, right? Because if you have $1,000 now, you could invest it, right? You could earn interest on it. You could do something with it. You could do all sorts of things that would generate value to you over the next 10 years that would have value, as opposed to getting that same $1,000 10 years from now. So $1,000 well into the future, that's not worth as much as having that money right now. Because if you have that money right now, you can do something with it. So very concretely, just as an example, you could invest it and let's say the interest rate's 5%. So $1,000, 5% interest, after 1 year, you have your same $1,000 plus $1,000 times 5%, or that's 1,000 times 1.05, you'd have $1,050, right? Your original $1,000 plus $50 interest. The next year, that $1,050, 1,000 times 1.05, that $1,050 now itself earns 5% interest. And the year after that, so it's 1102.5. The year after that, that $1,102 also earns 5% interest. This is what's called compounding interest, the magic of compounding interest. You get interest on the interest on the interest on the interest. And so after a period, it's not like you just get $50 interest every year, and so after 10 years you have $500 more dollars. You get interest on the interest on the interest. So after 10 years, here it was 1,000 times 1.05, then you got the interest the second year. After 10 years, you have the 1,000 times 1.05 to the 10th. I'm really not that concerned with you knowing exactly the formulas, although if you want to work through it, it is pretty self-explanatory, but there are also calculators that can tell you the present value. I really am mostly concerned with you understanding the concepts here. The idea that if you have $1,000 now, 10 years from now, it's going to be worth $1,629 at 5% interest. At different interest rates, of course, it will be different, and we'll talk about that. But so you could have $1,000 in 10 years, or you could have $1,000 now, which would be worth $1,629 in 10 years. And so clearly, $1,000 now is worth more than that $1,000 10 years from now. So if the benefit is going to accrue 10 years in the future, you're saying, what is that worth now? I can't say that $1,000 now is, the $1,000 in 10 years is worth paying $1,000 for now. So there's a project that will generate $1,000 10 years from now. What's it worth now? What would I pay for it now? I wouldn't pay $1,000. Certainly wouldn't pay more than $1,000. I would pay less than $1,000, but how much less? What is the present value of that future benefit? And so you can see, so the present value here is $1,000. You have $1,000 times 1 plus the interest rate, 1.05, times the number of periods is equal to the future value. I just took those numbers and turned them into an equation where, with with letters. But what it's saying is the present value of something times 1 plus the interest rate. So that's how the interest compounds and compounds and compounds, tells you what it would be worth in the future. So $1,000 at 5% interest over 10 years is going to be worth $1,629 10 years from now. But you can rearrange that, right? And you can say that in that case, the present value is equal to the future value over 1 plus the interest rate raised to the number of periods. That's just rearranging that equation. So this will tell us if we have a certain amount of money in the future, if we're going to get this $1,000 benefit in the future, what is that worth today in present terms? It's going to be worth something less than $1,000. What is it worth? What would I, if the project costs $500 now, should I do it? If the project costs $750, should I do it? I know it's worth something less than $1,000, but how much less? And so we can see if we have the interest rate, and we can say if the future value, if we're going to get $1,000 in the future, and the interest rate is 5%, and it's over 10 years, if we calculate that, I have that number here. I could pretend to do it in my head, but you won't believe me. $613.87. So that is $1,000 10 years from now has a present value. It's equivalent at a 5% interest rate, equivalent to getting $613 right now, $614 if you round. And so yeah, if the project is going to cost $500 in present value terms, and it's going to benefit us $613 in present value terms. So yeah, it would be worth it. And so that's what, when you're evaluating the costs and benefits of anything, you want to compare the present value of the costs to the present value of the benefits. And whoops, I should not, we always do benefits greater than or equal to cost. Let me do it in the other way. If the present value of the benefits is greater than the present value of the cost. So the whole concept of everything that we know about rational choice and taking action as long as the benefits are greater than the cost, that's all still true. All we're saying is that when you're doing that, when you're comparing the benefits to the cost and taking action if the benefits are greater than the cost, you really need to be, if the benefits accrue or the costs accrue into the future, you need to make sure that you're comparing the present value of the benefits with the present value of the cost. So if this project cost, so we know the present value of the benefits is $613. So if it costs $500, yeah, we'd do it. But if this project were going to cost us $750, it won't be worth it. $750 now to get $1,000 10 years from now, not worth it, because $1,000 10 years from now in present value terms is only worth $614. So that's the concept. Again, I'm less concerned with the formula, although it's pretty straightforward, and more concerned with you really understanding the concept that benefits or costs that happen in the future have lower value than if they happen right now. We discount the future somewhat because those things happen in the future. They're not as valuable because if they happen now, if we had that benefit now, we could be investing it or taking advantage of it in some way. So more concretely, I was mentioning college earlier. So let's say if you go to college, we're just going to keep this really simple. It will increase your earnings $30,000 a year for 40 years. So is it worth $30,000 times 40 or $1.2 million? Because $30,000 a year for 40 years is $1.2 million. So should you be willing to pay $1.2 million now for this benefit that's going to accrue year after year after year for 40 years? And let's just assume that we know this with certainty, because obviously there's also issues of not knowing for sure if it's going to be $30,000 a year and when it's going to accrue and what might happen to you and whether you'll live for 40 years or anything. So, but let's just assume we know this with certainty. So the benefits 1.2 million if you just multiply it, but getting that $30,000 10 years from now, 20 years from now, 30, 40 years from now, that's not the same as having that money right now. So if we want to say, what's this worth in present value, we want to say, we need to convert this. And this is not the same as the formula I showed you before, but the formula I showed you before was just in 1 year, in year 10, if we get this, what's it worth in present value? This is we have to calculate the present value of a stream of earnings. And honestly, that's not something I feel the need to show you how to do right now, although you can find it all sorts of places like Investopedia, and they all have calculators if you ever want to calculate it, and I can show you if you want. But more importantly, I want you to understand the concept. So what is it worth, $30,000 a year for 40 years? It depends. It depends on the interest rate, right? Think about this for a second. Is it worth more if the interest rate is, and that is in present value terms, if the interest rate is higher or lower? These benefits are accruing into the future. We're getting them in the future. What are they worth in present value terms? In present value terms, we're saying if I had it now, I could invest it. So it's worth more in present value terms if what you would get for investing it is bigger. But let me say, let's do something small. If the interest rate is 2%, then the present value of the 30 of that, call that X, so I don't have to write all over. The present value of getting $30,000 a year for 40 years, the present value of that stream of benefits is, I calculate this for you, 820,664. So definitely less than 1.2 million. But if the interest rate is higher, if what you could invest that money in is bigger, then the present value of that stream of payments is going to be what? Think about the present value. Remember when it was just a one-term thing, was equal to 1 plus the interest rate to the n. The higher the interest rate, the lower the present value. Because what we're saying is the interest rate tells us if we had that money now, what could we get if we invested it? And so if the interest rate is higher, we're giving up more by not having that money now. And so if the interest rate's 8%, this is 357,738. In either case, it's a pretty high return compared to what most people would pay for college. It's still worth it. It's still, but whether, I mean, that's a big difference when we're saying let's calculate the present value, because it sounds like we're doing stuff all very, very technical and exact because we have decimal points and things like that. But it matters if we had that money now, we can invest it for 2%. Well, then getting it in the future or getting it now isn't that different. Getting the 1.2 million stream in the future or getting it now, there's not that much difference. But if we could invest that money, instead of spending it on college, we could invest it in something else and earn 8%. Well, that's different. The opportunity cost of not having that money now is a lot higher. So if what we're giving up by not having that money is bigger, think of the interest rate as that. The interest rate is what we give up, shows us what we give up by not having that money now. It's not accruing for a long time. So when we're bringing it to present value terms, not having it now costs us a lot more when the interest rate's higher. So when we're calculating present value, this is sometimes referred to as the discount rate. And I think that is useful because you can think the higher the discount rate, the more you discount the future. The more, so the less weight you place on, the less value you place on things that happen in the future, the higher the interest rate. That's like you're giving up a lot more by not having that money now. And so when the interest rate is higher, you're discounting the future more. You're saying that future stream of benefits is worth less to me when the interest rate's so high. Because if I had it now, if I'm thinking about investing money now, I'm giving up an 8% interest rate. A lower interest rate, you're not giving up that much. So the value in the future isn't that much different than the value today. So the higher the discount rate, the higher the interest rate you could earn on your investment. The higher the discount rate, the more you discount the future, means the higher the discount rate, the less value you put on future things. And so the present, at a low discount rate, the present value of that future stream is over $800,000. With a higher discount rate, we're saying, yeah, $40,000 a year for 30 years, but if I had that money now, it's not worth it's really worth, it'd be like having $357,000 now, because I could invest it at 8%, right? And so the higher the interest rate, the higher the discount rate, the lower the present value of those benefits. That might take a little bit of thinking about. And again, I'm less concerned with the actual calculations and more concerned with you spending a little bit of time sort of thinking that through. And so you can see the choice of discount rate matters a lot if you're evaluating something. I mean, here, if college costs, $200,000 even, it would still be worth it, right? If these were the true numbers, but let's say it was an investment that cost $500,000. Like, should we do it or should we not do it? Well, it depends. Is the interest rate 2%? Then yeah, absolutely we should do it. Is it 8%? Absolutely we shouldn't do it. And so there's a lot of debate because there's no one necessarily what is exactly the right interest rate to use. And there's a lot of debate, particularly for government projects, should it be different? And so there is a lot of, in doing cost benefit analysis, a lot of discussion about what the appropriate discount rate is to use, because it can give you a very different answer. So sometimes what people do, and we're not going to get into the math of this, but you can see that 2%, let's say the cost is like I said, the cost is $500,000. You wouldn't do it at an interest rate of 8%, but you would do it if the interest rate was 2%. Sometimes what we do is calculate what's called an internal rate of return. And we, instead of saying it would be worth it here and it would be worth it here, we calculate what would the interest rate have to be to make us just indifferent, right? Something between 2 and 8 would make the present value exactly $500,000. And then we would say, okay, if we think, we're not sure exactly what interest rate to use to be very accurate, but this would be the one that would make us break even. So if we think a reasonable interest rate is higher than that, then we shouldn't do it. If we think a reasonable interest rate is lower than that, then we probably should do it. And this matters a lot. Like I said, there's a lot of debate over appropriate interest rates, particularly when there are things where the benefits accrue far into the future. Because you could say, here's what the interest rate is today, but if you're talking about things that are going to happen for 40 years and you're trying to discount them, you have no idea what interest rates are going to continue to be and things like that. So for something particularly like climate change, right, I have some numbers here. So if there's climate change and we're taking some action, and we know we have no idea what the true cost is going to be, but we could calculate for every $10 million in damages 100 years from now. This is just keeping it very simplistic just to illustrate this, but say in 100 years from now, what is the cost of climate change going to be? And that can tell us what is it worth to us investing right now. And you can say for every $10 million and at the rate we're going, without having mitigated it all, it's likely going to be obviously way. So this is just for each $10 million, of which there will likely be many 10 millions. But, and I'm not going to do the calculations for you, but basically, again, I use 2% and 8% just because just because to stay consistent. But I want you to take a second and think about this. Would we be willing to pay more to mitigate $10 million worth of damages if the discount rate is 2%? Or would we be willing to pay more to mitigate $10 million worth of damages if the interest rate is 8%? Take a second and pause the video even and think about that. In which situation would we be willing to pay more to mitigate $10 million worth of damage that's going to happen 100 years from now? Would you say? Obviously, I can't hear you. But remember, think about this as the discount rate. The higher the discount rate, the more we discount in the future. The higher the discount rate, the less value benefits that accrue into the future, like our higher pay, or costs that accrue into the future, like climate change. The higher the discount rate, the less value we place on things that are happening in the future. So the higher the discount rate, the less we value that cost. The higher the discount rate, less value on, this is not showing up very well, on future cost. So less willing to pay now to prevent damage. Does that make sense? So yeah, so if the discount rate is high, if we're discounting the future a lot, then those costs in the future have less present value. The present value of the cost are low, so the benefit of spending money right now or incurring costs right now is not that high because we're discounting the future a lot. If the discount rate's really low, we're not discounting, we're taking that more into consideration. And so I did calculate this. So at 2%, it would be worth spending $1.38 million now. So if our discount rate where we were evaluating the cost and benefit was 2%, we would say for every $10 million in damages right now, that's worth incurring a cost of $1.38 million right now to prevent that $10 million 100 years from now. But if we discount in the future more heavily, and the difference in the discount rate matters a lot when we're talking hundreds, 100 years, it makes a big difference. And so if we discount in the future more heavily and say that's going to happen 100 years from now, then it would be worth spending $4,500 right now to mitigate $10 million worth of damages in the future. And so you can see a lot of times when you see cost benefit analysis and you see these numbers and things like that, and it seems very concrete and calculated, but just this isn't a small manipulation of discount rate, but you can see how manipulating the discount rate and you're making your estimates, if you want to make it seem like we should be taking climate change seriously, you want to do your cost benefit analysis with a fairly low discount rate. If you want to make it seem like no big deal, we don't have to worry about it, we don't have to put that much into it now, you want to be doing it with a high discount rate. And like I said, there is no real concrete discount rate that is generally accepted. This is what you should be using, particularly for things that happen for a very long time or not for a long time to the future. So you can make a case for high or low. People can make a case for the discount rate that makes the story what they want it to be. And that's just something that you really need to always keep in mind when you're seeing things like cost benefit analysis, or when you're doing them, or when somebody's doing them in a firm that you're working for, or for a policy that you're interested in. It does matter. It's very important that you get the benefits and costs all in present value, so you know that you're comparing the same thing. You don't want to compare $10 million 100 years from now to $10 million now. You want to get in present value, but people will show you all those formulas like we had on the page and act like they know what they're doing, but what their answer can vary significantly depending on that discount rate. And that's just something that's really important for you to keep in mind.